In question number 9, we are given the graph of y is equal to fx, and in part 1a, we are supposed to sketch the graph of y is equal to f prime x. So the y coordinates that we're going to be sketching will be representing the gradient that we are interpreting from this graph. According to the sequence of consideration that we have discussed on the Achevas TV, I'm going to first look at the asymptotes that are here. There are two asymptotes. A vertical asymptote x is equal to -2 tells us that when x is equal to -2, there is going to be no gradient. The gradient is also going to be undefined there. So on this graph over here, we will also have a vertical asymptote. And that is when x is equal to -2. There's a horizontal asymptote here. So it is telling us that when x tends to plus or minus infinity, the gradient tends to 0. So we will be having a horizontal asymptote y is equal to 0 here. Next, what we will do is we will consider all the points where f prime x is equal to 0, and that is going to be here. B is when the graph is experiencing a stationary point, which means that the gradient when x is equal to 2 is equal to 0. So we are going to mark out, maybe let's say here. Okay, this is going to be the point where when x is equal to 2, the gradient is going to be equal to 0. So tentatively, let it be here. So we are going to be expecting our graph to be passing through this point. Next, I am going to, okay, that's all for those points where f prime x is equal to 0. So next, we are going to have an overview of where we are seeing all the positive gradients and negative gradients. And we are going to mark out regions where we're going to be experiencing positive y coordinates and negative y coordinates, which should synchronize to the gradients that we are seeing here. So to the left-hand side of -2, we are looking at positive gradients. So I'll be expecting my graph to be somewhere that is on top of the x-axis. Then from -2 all the way until b, it is experiencing a negative gradient. So from -2 all the way until b, which is when x is equal to 2, x is equal to 2 is here, we are going to be seeing our graph below the x-axis. And then from 2 onwards, the gradients are all positive. So from 2 onwards, we are expecting our graph to be somewhere here. So then the last step is actually to do an interpretation of the gradient that we are seeing from the left all the way to the right. So all the way to the left, we are seeing a gradient that is almost 0, but a small positive gradient over here. So the y coordinate will be a small positive gradient, and the gradient is going to become bigger and bigger and bigger as it proceeds towards x is equal to -2. So the y coordinate will just become bigger and bigger and bigger. So this part of the graph is going to be something that is like this, and is synchronized to the place that we have ticked. And for this, from -2 all the way until 2, we are seeing negative gradient, a very, very negative gradient when it was close to -2. So when it was to the right-hand side of -2, we are experiencing a very negative y coordinates for the graph, because the y coordinates here represent the gradient that we are seeing here. So negative gradient, and the gradient will become less and less negative, tending towards 0. So negative gradient, and the gradient will become less and less negative, tending towards 0. But the question actually gave me an additional piece of information. This is not common, but I think it is very interesting, or rather, I think the teacher has put in definitely quite a bit of effort, to make this question look more, to be teaching us even more about graph of y is equal to f prime x by adding in this additional piece of information, which is f prime 0 is equal to -4/3, which is what I've written down here. So at this point here, we know that the gradient of the tangent is -4/3, which means that here, this point here, when x is equal to 0, the value of the y coordinate, which represents the gradient that we are seeing, this particular point here will be 0. The value of the y coordinate will be the gradient, so -4/3. A very interesting point that is here where the information is given to us, okay, by the question. It's not common, but it's a good information to experience during when we are practicing. Next, okay, from 2 onwards, we are looking at positive gradient. The gradient becomes positive. In fact, the gradient becomes more and more positive. So the y coordinate will become more and more positive, which synchronizes to the place that we have ticked. Then at some point, which we cannot determine exactly where it is based on the graph, but we can observe that at some point, the gradient will still be remaining positive, but it will become less and less positive, going back to 0. So the y coordinate will become less and less positive, still positive, but less and less positive back to 0, tending towards the horizontal asymptote. So this is the graph of y is equal to f prime x. Next, let's go on to part B, where we are going to be sketching the graph of y is equal to 1 over fx. Okay, in part B, let's try to sketch the graph of y is equal to 1 over fx. And again, I'm going to try to follow the same sequence of consideration that we have been discussing on the Achevas TV. So we are going to look at all the asymptotes first. We have a vertical asymptote here, x is equal to -2. So this vertical asymptote will become an x-intercept. So we are going to be expecting it to be, let's say, somewhere here. Okay, so we are going to be expecting a point -2 and 0 here. That is derived from this vertical asymptote. And we have horizontal asymptote, y is equal to -2. And this will become a horizontal asymptote. Let's sketch it here. This will become a horizontal asymptote, y is equal to -1 over 2. Next, let's move on to the xy intercepts. We have this 2 x-intercept. X-intercept will become vertical asymptotes. So -4, x is equal to -4. We will have x is equal to -4 as the vertical asymptote. So let me sketch it here. This is going to be when x is equal to -4. We have x is equal to -3 over 2, and this will become another vertical asymptote. Let me sketch it here. So we have this as the other vertical asymptote. This is going to be x is equal to -3 over 2. And we have an x-intercept here. So when x is equal to 0, y is equal to -5 over 2, which means that when x is equal to 0, y is going to be 1 over this. So 1 over -5. So on here, we are going to be expecting here, maybe somewhere here. Okay, this is going to be a point which is going to be equal to, oops, I'm looking at the wrong point. It is actually this. So when x is equal to 0, y is equal to -5 over 2. So when x is equal to 0, y is going to be 1 over fx, which is going to be equal to -2 over 5. So -2 over 5 is bigger than -half. So let's say it is going to be somewhere here. So this point here, let me indicate it here. So it's going to be 0 and -2 over 5, the reciprocal of this value. And after we have done this, let's try to just do a test, an analysis from the left all the way to the right. All the way to the left, we are seeing the graph somewhere here. And in order for us to have a feel of how that part of the graph is going to be transformed to the graph of y is equal to 1 over fx, what we can do, like what we have discussed on Achevas TV, we can assign arbitrary coordinates to points that are here. So for example, although we don't actually know the coordinates of the points, I'm going to assign a point here with a coordinates, an arbitrary coordinate. So I'm going to just do an imagination, okay? So imagining this as somewhere to the, all the way to the left, so x is going to be -100. It is going to be a point that is slightly above -2. So for example, -1.9. And this point is going to be transformed to -100. And like how this point was being transformed to 0 and -2 over 5, it is going to become 1 over -1.9. And it is going to be smaller than -half. So it's going to be somewhere here. I'm going to put a point there. This point represents a point that is the transformed version of this. And as we go slowly towards -4, I'm going to poke another point here, and I'm going to assign arbitrary coordinates to this point. So for this particular point here, if I were to assign an arbitrary coordinates to it, it is somewhere to the left-hand side of -4. So let's go for, let's say, -4.1. And the y coordinates is a small negative value, so -0.01. And this will be transformed to -4.1 and a -100 on here. So I'm going to plot a -4.1 and -100, and that is somewhere here. Then joining here to that other new point, we'll have the graph that looks something like this. And after -4, we will have this over here. And for this, I'm going to assign arbitrary coordinate also. And I'm running out of space. So anyway, for this point here, I'm going to go for an x coordinate that is, let's say, negative 3.9 and a y coordinate of 0.01, which will be transformed to negative 3.9 as x coordinate and a 1 over 0.01, which is going to become a positive 100. So negative 3.9 and positive 100 is going to be somewhere here. It is going to go towards x is equal to negative 2. We have already marked it out. It is going to be here. So let me just draw my graph coming to here. Then coming towards negative 3 over 2, I'm going to poke a point that is here. The y coordinate that is here, just like this, is going to be 0.01. If I were to assign arbitrary coordinates to this point, and 1 over 0.01 is positive 100, it is going to be somewhere here. So from here, I'm going to continue upwards and joining to this. Then I'm going to poke a point that is here. The y coordinate is negative 0.01, an arbitrary coordinate point. 1 over negative 0.01 is negative 100, so we have it at somewhere here. It is going to be joined to here, so let me move this up all the way until this point. Then after that, it will go to this point, which is 2, negative 5 will become 2, negative 1 over 5. So let's say it is going to be somewhere here. So coming to this point here, and I'm going to mark this point as 2 and negative 1 over 5. Then after that, it's going to come to a point that is, say, here. A point that is here will be, let's say, x is positive 100 and y is going to be negative 2.1, which will be transformed to positive 100 and 1 over negative 2.1, which is going to be bigger than minus half. So from here, I'm going to go to a point that is bigger than minus half. So since it's a horizontal asymptote, I'm going to sketch it in this way. So now we have the graph of y is equal to 1 over fx. And the last part of this question requires us to, by adding a suitable graph to our diagram in this here, we are supposed to try solve the inequality. Let me write down this inequality. We are supposed to solve for this. The very last part here, part 2. We are supposed to solve for 10 over fx plus x plus 4. This is less than or equal to 0. So the graph that we have here is the graph of y is equal to 1 over fx. If I'm supposed to be sketching another graph that is on here in order for me to solve this inequality, what we will be expecting ourselves to be watching out for is how a simultaneous equation is going to be formed here, where the intersection between the graphs will somehow give me an insight to how I'm going to solve this inequality. So I'm going to treat this as if I am trying to work on some kind of simultaneous equation. I'm going to try to reorganize this inequality that is here, okay? So since this is 1 over fx, I'm going to try make one side to be like 1 over fx. So this will be negative x, negative 4. So this is going to be less than or equal to. So if I were to divide by 10 on both the left and right hand side, it is going to be 1 over fx. This is going to be less than or equal to negative 1 over 10x. 4 over 10 is going to be equal to 2 over 5, which means that the second graph that I'm going to be sketching on here, the second graph, let me write it down. The second graph that I'm going to be writing down, that I'm going to be sketching here on here, as if I'm trying to solve a simultaneous equation, is going to be the graph of y is equal to negative 1 over 10x minus 2 over 5. And if I'm sketching this graph over here, this graph is going to be passing through the point, the y-intercept, 0 and negative 2 over 5, which is here, 0 and negative 2 over 5. So the graph will be passing through this point. Then when y is equal to 0, let's test, okay? When y is equal to 0, negative 1 over 10x, negative 2 over 5, this is equal to 0. And we will be getting x to be equal to negative 4. And where is x is equal to negative 4? When x is equal to negative 4 is here. So this point tells us that the graph is going to be passing through negative 4, 0. And negative 4, 0 is here, negative 4, 0. So exactly here, that is on the vertical asymptote of the graph of y is equal to 1 over fx. So we have our first graph as this, our second graph as this. If I were to draw both graphs here, where one of them is already here, the graph of y is equal to 1 over fx, The other graph is going to be passing through this point and this point. Let me join them together. So we have this, right? We have a graph that is like this. So this here is going to be representing for us the graph of y is equal to -1 over 10x minus 2 over 5. And we are supposed to be solving for the y of this to be less than or equal to the y of this. Looking at the graph, when will the y coordinate of this be less than or equal to the y coordinates of this? It is going to be this portion, right? Where the black colored graph is going to be below the red color graph, below or equal to the red color graph. So it's going to be this region here for x, and when the black color graph is below the red color graph, it's going to be this region here, below or equal to. So based on what we are seeing now, we know what is our answer. Our answer is going to be this region. So x is going to be strictly less than -4, or the other region is this, where x is going to be strictly bigger than this value, which is -3 over 2, but it can be equal to this because we are talking about this to be less than or equal to. So at this point here, it can be equal to, and that is when x is equal to 0. Okay, so this is going to be the part 2 of the question. We have answered it. Let's move on. Let's move on to the next question. Question number 10 over here. This is a functions question. Okay, let's take a look at question number 10. So we are given the function, two functions. We are given function f and function g. They are defined for us already. In part 1 of the question, we are going to be letting k to be equal to 1, which is affecting the function f. So let me write it down. So in part 1, we are looking at the function f as this. So we have x to the power of 3 minus 7x squared minus 5x plus 11, where x is supposed to be bigger or equal to k. In this case, it is bigger or equal to 1. And for the function g, let me write it down also. G is such that we have this, and it is a quadratic polynomial as this expression. And x is just simply all real numbers. In part A, show that f does not have an inverse. So what I'm going to do is I'm going to just sketch a graph of f. So using my graphing calculator, sketching the graph of y is equal to fx, we have it as something that is like this. So if this is the x-axis, it is going to be something like this, going all the way up. This is the graph of y is equal to fx, where x is supposed to be bigger or equal to 1. So this is at x is equal to 1. From the graphing calculator, this point here is 7.471. And as for this point here, the minimum point is interesting because the minimum point actually has a super negative y coordinates. It took me a little while to zoom to get this point, but anyway, we can see it from our calculator, so we will just zoom accordingly. The y coordinate here is -64. So we are trying to show that f does not have an inverse. I'm going to use a horizontal line to discuss about it. A horizontal line, any horizontal line that can probably make it fail the one-to-one function test, which is maybe a horizontal line that is anywhere that is between -64 and 0. So I'm going to just discuss about one. How about just making use of, let's say, the line y is equal to, let's say, -10. Okay, it is going to be a line that is in between. In fact, any line that is in between will do. So since this line, y is equal to -10, cuts the graph of y is equal to fx at more than 1 point. F is not a one-to-one function. Therefore, f inverse does not exist. Okay, so this is part A. For part B, we are supposed to determine whether the composite function fg exists. For fg to exist, let's use the same schematic as what we have again on the Achevas TV. So for fg to exist, we are looking at the flow of x to be first going into g, then after that it's going to go into f, right? From inside out. So first to G, then after that to F. So in order for this to be happening, we need to make sure that the connection is made possible. And the connection is possible when everything that comes out from G, the range of G, I must be able to show that everything can be received by F. So everything that comes out from G must be a subset of the domain of F. What is the domain of F? We already know the domain of F, according to what we have here. The domain of F is going to be X is bigger or equal to 1. So we are going to try to find out what is the range of G. So we are trying to find out, oops, I wrote wrongly. So here it should be G. So this is going to be the range of G. Okay, everything that comes out from G must be a subset of the domain of F. So we are going to try to find the range of G. To find the range of G, let's sketch a quick graph for the graph of y is equal to gx. It's easy to sketch. It is a parabola. Y is equal to gx, where in its completed square form, we know that the minimum possible point here is -1, 2. So based on this, we can see what is the range of G, and that is going to be from 2 all the way until infinity. How about the domain of F? The domain of F is given to us here. So the domain of F is going to be from 1 all the way until infinity. Everything that is going to be in the range from 2 to infinity can be accepted by the domain of F from 1 to infinity. So this is a subset. Therefore, we can say that the composite function fg exists. Okay, this is for part 1. Next, I want to find the value of k given that f inverse exists and that the domain of f inverse is such that it is real number and x is supposed to be bigger or equal to -24. Okay, I better erase this first. In part 2, we are going to be changing the value of k. In fact, we are going to be finding the value of k. So we are going to revert back to from 1, we are going to revert back to x is supposed to be bigger or equal to k. And according to what the question says, f must have an inverse. Okay, in part 2, f must have an inverse. So if x is supposed to be bigger or equal to k, which that would mean that it is going to be this side, right? This side of the graph. Okay, because x is supposed to be bigger than a particular value and it must pass the horizontal line test. So it's going to be on this part of the graph, and we are going to make sure that the domain of f inverse is such that x is supposed to be bigger or equal to -24. So the domain of f inverse is going to be from -24 all the way until infinity. That's what the question says. And what is the domain of f inverse? The domain of f inverse is the same as the range of f. So looking at this graph, this is the graph of y is equal to fx. And in order for me to analyze the range of f, which is this, from -24 to infinity, I'm going to draw a horizontal line here just for my own reference. This is going to be the line y is equal to -24. And according to the question, the range of f must be from -24 onwards. So we're going to be looking at from this part upwards. Okay, from -24 onwards, which means that k must be this value here, right? K must be this particular value because like what we have discussed, x must be bigger or equal to k, and then it must be a one-to-one function. So the minimum possible k can go is actually 5. It cannot go anywhere that is less than 5. And this value here is definitely going to be giving us an x that is less than 5. So working on the part of the graph that is to the right-hand side of x is equal to 5, and at the same time, it is going to be producing for us a domain of -24 all the way until, it's going to be producing for us a range of -24 all the way until infinity. We need to find out what is this value. Using our calculator, this value here is 7. Okay, so which means that based on the requirement of the question, when y is equal to -24, then x is going to be equal to, actually probably we should write fx. It is more accurate. So when fx is equal to -24, we are going to be expecting x to be equal to 7. So x is going to be equal to 7. Therefore, this tells us that the value of k should also be equal to 7 in order for this condition here. In order for the inverse function here to satisfy both the condition that is mentioned by the question. Next, k is going to change again. Okay, so let's erase this. So in part 3, k is going to change to 6. So x is going to be bigger or equal to 6. We are supposed to show algebraically that f prime x is bigger than 0 for all values of x such that x is bigger or equal to 6. So let's try to find out what is f prime x, and that is going to be equal to 3x squared minus 14x minus 5. And this can be factorized to 3x plus 1 and x minus 5. And the reason why I am factorizing this is because I can then now discuss that when x is bigger or equal to 6, when x is bigger or equal to 6, looking at the expression of f prime x, it composed of f prime x is this multiplied by this. So when x is bigger or equal to 6, we have a 3x plus 1 that is definitely going to be a positive expression. And we have a x minus 5, which is also definitely going to be a positive expression. So when a positive expression multiplied by a positive expression, we have a 3x plus 1 multiplied by this, which will remain as positive. This tells us that f prime x, which is actually this, is also going to be bigger than 0. This is what the question wants us to show. Next, part B. Part B says that we are supposed to solve this inequality. We are supposed to solve that g f inverse x here, this is equal to 83. Okay, g f inverse x is equal to 83. We are supposed to solve this, which means that we are supposed to find the value of x that satisfies this equation. So from what we can see so far, g is this expression. It has not changed. It has remained consistently as this. So how about re-expressing this to be in terms of f inverse x first? Which means that if I were to see this as g of the input, which is going to be f inverse x, this is equal to 83, and gx is equal to this, I'm going to replace all this x by f inverse x. So we will have a bracket x. Let me just put in as a bracket first, okay? So we have a x plus 1 square, then plus 2. This is going to be equal to 83. So this x here is going to be now replaced by f inverse. So we have this, which means that f inverse x plus 1 square is going to be equal to 81. So this tells us that f inverse x plus 1 is going to be equal to plus or minus 9, which means that f inverse x is going to be equal to negative 10, or f inverse x is going to be equal to 8. So if f inverse x is equal to negative 10, x can be found by doing a f of negative 10, correct? We just shift f inverse over to the right hand side. Can we do a f negative 10? We can't. You know why? Because x is supposed to be bigger or equal to 6. The domain of f is supposed to be bigger or equal to 6. And that means we cannot substitute any value that is less than 6 into the function now. So this is not applicable because we need to make sure that x is supposed to be bigger or equal to 6. How about this? X is going to be equal to f8. Okay, now this is possible. And what is f8? Using that, we have 8 to the power of 3 minus 7 times 8 squared minus 5 times 8 plus 11. This gives us the value of x. It is equal to 35. Let's move on. Okay, so in this question number 11, we are supposed to try to find out the outstanding amount of money that Mrs. Yu were to owe by the end of the nth year. So I'm going to build for myself a little table here to try to analyze the amount of money that she owes in the year 2020, which is the first year when she borrowed the money. Then after that, 2021, 2022, and hopefully we will be able to see some kind of pattern that can help us to generalize and predict what is going to happen during the nth year. So during the very first year, which is the year 2020, first year, Mrs. Yu, she is going to be borrowing $20,000. and on the 30th of December, she will be repaying back X amount. And on the 31st of December, and that is actually the end of the year, which means that for this end of the year here, we are defining as 31st of December. So by the end of the year, the bank is going to be imposing a 4% interest. So this will give us the amount of money that Mrs. Yu owe by the end of the first year. And what we are going to try do is we are going to try to rearrange whatever that is here, and hopefully by taking a look at the details, this is the detail according to the information that is given, we will be able to categorize and rearrange them so we can put the similar stuff together. Okay, I'm going to leave a bit of space here in case I need to rearrange this further. Let me jump to the second year first, which is going to be 20,000 minus X, then multiply by 1.04 to begin with in the beginning of the year. By the end of the second year, she's going to be repaying back X amount, and the bank is going to be imposing a 4% interest. And I can see the numbers repeating. And if I were to try to regroup whatever that is here, I am going to, if I were to look at this, okay, and I would look at this, I'm going to regroup those that has 20,000 together and those that has X together, because this seems to be two distinct enough categories. For example, like this, without mixing them, okay, that means this times this, I'm going to just leave it as this so I can see the whatever pattern that is probably existing as clearly as possible, minus 1.04x. Okay, this is obviously not possible for me to like merge them together into one number, but I'm going to keep it as this. And which means that for what I have here, okay, this I'm also going to rewrite as this portion here. So it's going to be 20,000, then multiply by 1.04 minus 1.04x, then minus x. And I'm going to be multiplying this by 1.04. And if I were to multiply in, I think I'm seeing a pattern now, because it is going to be 20,000 1.04 square minus away 1.04 square x minus away 1.04x. So it seems like there's a pattern here, then followed by another pattern, because it is pretty consistent. And of course, we should be able to guess that this belongs to APGP. So for this term here, I'm going to just leave it as it is for now, 1.04 square. But for this, right, because we are working on APGP, so because we know what we are expecting, so I'm going to rewrite this by factorizing out negative. And I'm going to write down this first. So 1.04x, then plus 1.04 square x. So I am suspecting that there's a pattern that goes on for this 20,000. Then after that, it is going to be some kind of sum of a GP probably, with one that is with a common ratio of 1.04. Let's verify this by going for the third year. So the amount that Miss Yu will be owing in the beginning of the year is going to be this x plus 1.04 square x, and she'll be repaying back X amount on the 30th of December, and the bank is going to similarly impose a 4% interest. So this is going to be this multiplied by this. We have a 20,000, then 1.04 to the power of 3 minus away, grouping all the x together. This times this gives me a 1.04x. This multiplied by this gives us a 1.04 square x. This times this is a 1.04 cube x. So we do see a GP happening here. So let's make a guess by predicting whether the pattern that we are seeing is really going to be true, and especially we can show what that is there, so it will help us to verify also. So the very first term that is here, which is going to be 20,000, then 1.04 to the power of something. So this something here, this index here, is going to be changing. For the first year, it is power 1. Second year, power 2. Third year, power 3, which means that the nth year, it should be power n. Okay, I'm just following the pattern that we have written down. Minus away, this is obviously a sum of a GP. So this GP has the first term as 1.04x, and it has a common ratio of 1.04, and it is going to be to the power, if I were to use the sum of GP formula, here's going to be the number of terms, And for the first year, it is 1 term. Second year, 2 terms. Third year, 3 terms. Nth year, I'm going to be expecting n number of terms. Minus 1 divided by the common ratio minus 1. Let's simplify this. We have 20,000, then 1.04 to the power of n. Minus away this divided by this, I'm going to be getting a 26x. Then 1.04 to the power of n minus 1. In fact, I think I probably should just rewrite this. Okay, it's not necessary, but just to make sure that I'm writing an expression that is exactly the same as what I'm trying to be showing. It is a 1.04 to the power of n multiplied by 20,000. Okay, and this is what the question requires me to show. Shown. And according to what the question says, we are also supposed to be showing what we are also supposed to be determining the value of k. So this is the value of k. Therefore, k is equal to this number here, which is 26. And in part B, we are supposed to determine the value of x. This is the x. We are supposed to determine the value of x if Miss U is intending to repay the loan fully, which means that the amount of money that is going to be owed by the end of the year 2024, fully returned, so fully repaid. So by the end of 2024, we will be expecting that the amount that is outstanding to be equal to 0. But first, we got to find out what is n. 2024 represents n. Okay, what is the n that is going to be representing 2024? So something that I like to do is, since it's not that far away, I like to manually count. So, like for example, 2020 is year number 1. Then 2021 is year number 2. 2022, it is year number 3. 2024 is year number 4. Sorry, here is 2023. Goodness, I am trying to count, okay? So 2024, this is going to be year number 5. So we are talking about n to be equal to 5 when it is the year 2024. So letting n be equal to 5, we will have a 1.04 to the power of 5 times 20,000. Then minus away 26 times x. Then 1.04 to the power of 5 minus 1. I'm letting this be equal to 0. And then working out the value of x, which is going to be equal to 1.04 to the power of 5 multiplied by 20,000 divided by 26. 1.04 to the power of 5 minus 1. So x here is going to be equal to the amount of money is 4319.75. Okay, let's move on to part 2. Okay, and now in part 2, which we have quite a lot of information to be reading. And after we have finished reading and sort of like getting the logic of the information that is given, we are supposed to find the month and the year in which Miss U will be withdrawing the money from the fixed deposit. So in the beginning, she's going to be saving into this account. So the first time when she saved, that is going to be in 1st of July 2020. Then after that, in the next month, she's going to be saving $50 more than the previous month. So it's going to be this amount. Then after that, she's going to do the same thing, $50 more than the previous month. So it's going to be 2 times of 50. She's just going to continue. So what we are seeing here is already an AP, right? It's a sum of an AP. Okay, it's a sum of an AP where the first term is 1600 and the common difference is plus 50, plus 50, plus 50 from one term to another term. So if we were to write down, let's say, n number of terms here, we are looking at the situation when the amount of money that is inside here is supposed to be exceeding 35,000. So we want this to be more than 35,000. Applying the sum of AP formula, it is going to be, if it is n number of months, so it's going to be n over 2 times of the first term, plus n minus 1 multiplied by the common difference. So this is supposed to be bigger than 35000. I'm going to try to find out when exactly the total amount that she saved in the first account is going to be more than 35,000 by pressing this into the calculator and generating for myself a table where n is going to be represented by x on my calculator and y1 is going to be representing this. So we have an n over 2. Let me just recopy this. So 1600 plus n minus 1 times 50. So if I were to scroll down the table that is generated by my calculator, when n is equal to 17, the amount that she would have saved is going to be 34,000. We are looking for something that is more than 35,000. During the 18th month, she will be saving 36,450. And on the 19th month, if she were to actually continue, she would have saved this amount, which means that on the 18th month is when her savings is going to be more than 35,000, which means that on the 18th month, this is when she's going to be transferring the money to the fixed deposit account. 18th month, okay, it is a little bit hard for us to immediately say which is the month and which is the year. So like what I did in the previous part, I will try to manually count, okay, which is the exact month and year is this 18th month representing. So if I were to just do the counting, July, let's use the 3-letter for month, July 2020, we are talking about the n is equal to 1, the first month. And in August, next one is August 2020, this is going to be 2. How about September? Let's write one more. September 2020, this is going to be equal to the third month. So we can see 7, July 7, then 1, minus 6, 8, minus 6, 2, 9, minus 6, I'm going to be getting a 3. So if I were to just keep continuing to December 2020, minus 6, minus 6, minus 6, right? Which means that by December 2020, we will be getting n to be equal to 6. Then we will move on to January 2021. And that is going to be 7. If it is February 2021, we are going to be getting the 8th month. So again, if I were to try manually counting it this way, to me it is very, very clear and it's not actually going to be taking a lot of time. Instead of me trying to do a lot of mental sum, especially during the exam, we are going to be panicking a little bit. So I think this is actually a little bit, it works a little bit better for myself. So January 2021 plus 6, I get a 7. This 2, February 2, plus 6, I get an 8. So what I'm going to try to do is, I'm going to go all the way until 18, which means that if I were to reverse back our minus 6, right? Plus 6, plus 6. So here, if I were to go back our minus 6, which means that it is going to happen in December 2021. This is when the amount of money that she has saved in the first account is going to exceed 35,000, and she's going to transfer that money to the fixed deposit account. So let me just write down, okay. No interest account. Let me just write that here. No interest account. So she is going to transfer, no interest account. She's going to be transfer out. So transfer out from her no interest account. When is this going to be happening? This is going to be happening in December 2021. And she's going to be transferring this immediately to the fixed deposit account. So let me write down from the fixed deposit account and fixed deposit account. This fixed deposit account will actually be giving her an interest, and she's going to be keeping the money in there for 12 months. So when will she be withdrawing? Fixed deposit account withdraw. Okay, let me just write it down here. She will be withdrawing 12 months later. So from here, I think it is easy. 12 months later is going to be in December 2022. So this actually answers for us part A. Find the month and year in which Mrs. Yu will be withdrawing from the fixed deposit account, that is in December 2022. And we are supposed to determine the value of the fixed deposit account that Ms. Yu will be withdrawing during this year. So the amount of money that she's going to be transferring is this amount, right, from the first account. So, and this amount here is going to be subjected to an interest that is going to be paid by the bank, 1.5% interest. So the amount it is actually for this. So maybe I will just write from here onwards, okay? So the amount that she will be getting when she withdraw money from here, so amount that she's going to be withdrawn, this is going to be the amount that she has deposited during this year. Okay, this is when she transferred the money over. The amount that she deposited is 36450, and the bank is paying a 1.5% interest. So I'll multiply this by 1.015. So this will be the amount that she's withdrawing. It is going to be 36996 and 75 cents. Let's look at the last part. Okay, now in part 3, we have two options that are given to us. Let me write down option 1, and we have another one, which is going to be option 2. So for option 1, she is going to be depositing $30,000, which is going to be given a simple interest of 1.5% per year. So let's say we are going to be working on 1 year. 1 year is going to be, well, this is a 1.5% interest. So 1.015, this is going to be multiplied to 30,000. Okay, so if she were to put in the money for 1 year, this is going to be the interest. This is going to be the interest that she will be getting. Sorry, interest. So I'll put 0.015. So this is the interest that she will be getting. And what if she were to be putting in for n number of years? So let's try to see whether we can get a more generalized version of how much money she would be getting, how much money is going to be in her entire fund, okay, by the end of the nth year. And this can be simplified to, let me write it down, this can be simplified to 30,000 plus 450n. As for option 2 is going to be a compounded form of interest. She's still going to be putting in 30,000, and every year the bank is going to be giving a 1.2% interest compounded. So it is going to be 1.012 to the power of I mean this is going to be multiplied, right? It's because it's going to be a compounded interest. So the total amount of money that is going to be in the account by the end of the first year is going to be this, and the second year this is going to be multiplied by another 1.012. Third year is going to be multiplied by again. So second year this multiplied by another 1.012. So it will be this to the power of 2. Third year is going to be multiplied again by 1.012 to the power of 3. So if you are comparing n number of years, like here, it is going to be to the power of n. And let's try to find out when exactly this amount of money, okay, this is the total amount of money that she's getting if she were to go for option 2, will be more than the total amount of money if she were to be going for option 1. So I am going to let 30,000 1.012 to the power n, option 2, to be bigger than 30,000 plus 450n. We want to know when exactly this amount, this total amount of money that is in a fund, will be more than this. So I'm going to try to solve this inequality. N is an integer value. Let's move everything over to one side. So if I were to move everything over to one side, we will have this 30,000 plus 450n to be bigger than 0. I'm going to create for myself a table looking at the year and this expression here, 30,000 and 1.012 to the power of n minus 30,000 plus 450n. If I were to scroll down the table, during the 37th year, this is negative 5.524, which means that during the 37th years and before, okay, you can actually see that the numbers on the table, they're all negative, which means that this is not happening. Okay, which means that before 37th year, option 1 is actually giving her more money. But on the 38th year, during the 38th year, this is 104.21, and then after that, it is going to be positive all the way. Which means that from the 37th 38th year onwards, option 2 is going to be giving her more money than option 1. So for Miss Yu, how will we advise her? So it really depends on what she sees as a long run. So if she's planning to get more money within the first 37 year, so if n is less than or equal to 37, so if she's planning to get more money, if she's planning to take out her money before the 37th year or on the 37th year, she should go for option 1. Okay, because according to what we have discussed, what we have analyzed here, option 1 will be giving her more before the 37th year. Then if she's going to be looking at her long run as 38 years and beyond, then she should go for option 2, because the moment she went for the 38th year, she's going to be getting more money based on option 2. Okay, a very, very easy question to write as solution, but a really tough question to be analyzing during the exam. Anyway, let's move on to question number 12. In question number 12, part 1, we are looking at 2 lines. The very first line, let me draw it here, okay? The very first line is going to be, according to the question, is going to be passing through A1, and it is going to be passing through F1. And the second line, let me draw it here. So let's say this is L1, this is L2. The second line is going to be passing through the point A2 and the point F2. The question gave me the coordinates of all the 4 points here. So for A1, let me just write it down. A1 is going to be 61 over 3, 0, and 28 over 3. As for F1, it is given to me by the question as this. For A2, the question gave me the information as this, over 3, 0, and 28 over 3. And for F2, this is negative 20, 5, and 10. These 2 lines, they are actually going to be intersecting. And according to the description that is given to us by the question, it is going to be intersecting at A, the tip, the highest point that is going to be on the flagpole. Okay, this point A. So we are supposed to be writing down the vector equations of L1 and L2. So for L1, the direction that is parallel to L1 can be found by going for an A1 F1. So A1 F1 is going to be OF1 20, 5, 10 minus away OA1, which is going to be 61 over 3, 0, 28 over 3. So this is going to be equal to negative 1 over 3 and 5, and also here we will have a 2 over 3. And because we are taking A1 F1 as a direction that is going to be parallel to L1, so I guess I'm going to try to factorize out 1 over 3, which will give me a negative 1 over here. This is going to give me a 15. This times this gives me 5. And factorizing out 1 over 3, this here gives me 2. So L1 is going to be parallel to this, which means that L1 can be written as R is equal to, I'm going to make use of the fact it passes through this point. So 25, 10 plus lambda of minus 1, 15, 2. This is for L1. Next, let's find out about the equation of the line L2 by first finding a direction that is parallel to L2, and we can do that by going for A2F2. A2F2 will be negative 20, 5, 10, OF2 minus away OA2. So minus away negative 67 over 3, 0, and 28 over 3. This is going to be equal to, let me write down the scaled version of this. So it is going to be equal to 1 over 3 of 7, 15, and 2. So which means that for L2, it is going to be passing through this point, this point. I can use either of them. I'm definitely going to be using the simpler looking point. So it is going to be minus 20, 5, 10 plus mu of a direction that is parallel to L2. We can either use the entire one, or let's just use this 7, 15, 2. So this is L2. And in order for us to be finding the coordinates of point A, that's what the question asks, right? We are supposed to find this coordinate. What is so special about point A? It is the intersection between L1 and L2. So at point A, we can sort of like solve simultaneous equation. This is equation number 1, this is equation number 2. They will be sharing the same R, the position vector of a point that is going to be on each of the lines. So at point A, they are going to be sharing the same position vector for that particular point. So R is going to be equal to R. So at A, it is going to be, so this looks like A1, right? So at point A, this is, I'm going to be letting 20, this 20 minus lambda, 5 plus 15 lambda, and 10 plus 2 lambda. I'm going to be letting this be equal to this. So it is going to be minus 20 plus 7 mu, 5 plus 15 mu, and 10 plus 2 mu. So from the first row, for the first row, we will have a 20 minus lambda is equal to minus 20 plus 7 mu. This gives us our first equation, lambda plus 7 mu. This is equal to 40. This is equation number 1. Second row, we have a 5 plus 15 lambda is equal to 5 plus 15 mu. This tells me that lambda minus mu, this is equal to 0. This forms for us equation number 2. The last row here, 10 plus 2 lambda is equal to 10 plus 2 mu. This similarly gives me a lambda minus mu is equal to 0. Equation number 3, I can either solve them manually or I can just simply press this into our graphing calculator. So for my calculator, I'm going to be getting lambda to be equal to 5 and mu is also going to be equal to 5. So for the position vector of A, I can either substitute lambda into here to get OA, or I can sub mu into here. I will still be getting OA. So let's go for this to be here. So therefore, OA, the position vector of A, is going to be equal to 25, 10 plus lambda, which is 5 of minus 1, 15, 2. And OA here is going to be equal to 15, 80, and 20. And the question asks us for the coordinates of A. So we should be writing our answer in coordinates form. It is going to be 15, 18, 80, and 20. So this is for part 1. Next, in part 2, we are looking at a plane P. And according to what the question says, this plane contains a point D and it contains a line L. Let me just do a quick sketch of this plane. So this is plane P. It contains the point D, and this point D has a coordinates of 75, 90, and negative 50. And this plane contains a line, this line L. Line L with an equation that is given to us as 23, 90, negative 46 plus, according to the question, let me just reread it again. This is going to be plus S of negative 161. So information that we have obtained from this line is that it is going to be passing through a point with a coordinate of 23, 90, and negative 46. And this line is going to be parallel to a vector minus 161. So in order for us to form the equation of the plane in the dot product form, in a vector equation form, we will take this. We will take this vector over here from one point to another point to be one that is going to be giving us information about a vector that is going to be parallel to the plane P, right? So if I were to take this vector can be found by taking 75, 90, negative 50, okay, of a point that is on the plane, then minus away the position vector of another point that is on the plane. So this minus 46. These 2 points are on the plane, so if I were to find this particular vector, it will be a vector that is going to be parallel to the plane. This minus this is going to be giving us a 52, 0, negative 4. I am going to factorize out 4, which will give me a 13, 0, minus 1. So I know that 13, 0, minus 1 is going to be parallel to the plane P. We also know that minus 161, which is going to be parallel to the line L, and this line L is on the plane P. So minus 161 is also going to be lying on the plane P. Let's find the normal vector, or a vector that is parallel to the normal vector. So I'm going to take this 13, 0, minus 1, cross this, minus 1, 6, 1. This cross this will be giving me 6, negative 12, and 78. We can actually factorize out 6. It gives me a slightly nicer looking numbers. This entire question has numbers that are so huge. So anyway, now we know that the normal vector is going to be parallel to 1, minus 2, 13. So I guess we can find P. P will be R dot normal vector. I'm going to use 1, minus 2, 13. It's going to be equal to the position vector of a point that is on the plane. I can either use this point, or I can also use this point. So let's say I use this point here. It is 23, 90, negative 46 dot 1, minus 2, 13. This is going to be equal to 23 minus 180 minus 598. So for the plane P, R dot 1, minus 2, 13, this is going to be evaluated to be negative 755. And this is what the question wants us to show. Next. So for part 3, we have this point A, which is the tip of the at the tip of the flagpole, and this flagpole is going to be perpendicular to that plane, the plane P that we have just found. And this base here, according to what the question says, this base here is point B, and we are supposed to find the coordinates of this point. So let me just write down the numbers that we have found previously. For the plane P, it is also shown, we have also shown it. The equation, the vector equation is this, negative 755. For point A, we are given the coordinates. We found the coordinates. So this is this, 80, then 20. We're going to use a process to find B, a process that we have discussed on Achevas TV, which is to form a line that passes through AB. So R is going to be equal to, it passes through point A. So I'm going to use this 15, 80, 20 plus, let me use T. Okay, a direction that is going to be parallel to AB. What is the direction that is going to be parallel to AB? I'm going to make use of this, the normal vector to the plane. Because the normal vector to the plane is going to be perpendicular to the plane, and henceforth it is going to be parallel to AB. So it is this 1, minus 2, 13. So the line that is going to be passing through AB is this. And at point B, that is when this line intersects the plane. Which means that what I'm going to do is, I'm going to try to solve a simultaneous equation again, because it is the intersection between the geometry, which means that the R and the R, they will coincide. So let me substitute this R into here. So this R is 15 plus T, 80 minus 2T, and 20 plus 13T. So this substituted inside, it is going to be 1, negative 2, 13. This is negative 755. And working this out, we have a 15 plus T, then negative 160 plus 4T, plus 260 plus 1690. This is equal to negative 755. We will be able to work out a value for T. It is equal to negative 5. And substituting this back into here should give us the position vector of B. So this is going to be equal to 15, 80, 20 plus T, which is negative 5. Then after that, it is going to be this 1, negative 2, 13. So OB here is equal to 10, 90, and negative 45. And what the question is asking us for is the coordinates. So therefore, the coordinates of point B is 10, 90, and negative 45. Next, in part 4, we are supposed to find the length of this flagpole. The length of flagpole is just going to be AB. So let me find first the vector AB. It is going to be OB minus OA. So OB is 10, 90, minus 45, minus away OA, 15, 80, 20. AB is going to be equal to -5, 10, and -65. So the length of the flagpole is going to be modulus of AB. It is going to be square root of 5 square plus 10 square plus 65 square. So the length is going to be equal to square root of, let me write it down, 4350. If you want to press this into the calculator, to 3 significant figures, we have 66.0. And the very last part, part 5, we are going to be looking at the angle that is between the plane P. Let me just draw plane P first, okay? So plane P, this is like r dot 1, -2, 13. This is -755. So we are looking at an angle that is between this plane P and the horizontal plane. This horizontal plane is going to be modeled by the XY plane. So for the XY plane, let me just write down XY plane, okay? XY plane, it should be r dot. What is the normal to the XY plane? The normal to the XY plane should be parallel to the Z axis, right? XY plane, let's say it is here. So normal is going to be parallel to the Z axis. So we do know that it is going to be 0, 0, 1. So it is going to be this is equal to some numbers on the right hand side. I'm going to just skip it because we do not actually know whether it is going to be passing through the origin, because if it is passing through the origin, this will just be 0. So the question says that this horizontal plane is modeled in this model is the XY plane. Okay, actually XY plane should be passing through the origin. So origin 0, 0, 0 dot this is going to be equal to 0. That is why I was saying that if we know that it passes through the origin here, it's going to be equal to 0. We are supposed to find this angle theta. And according to the strategy that we have discussed on the Achevas TV, in order for us to find this theta, we are going to work on the normal vectors instead. So for this, the normal vector is going to be perpendicular to this plane. This is 0, 0, 1. As for this, the normal vector is going to be perpendicular to this. So this is going to be 1, -2, 13. So this is 90 degrees here. This is 90 degrees here. This plus this is going to give me 90 degrees. This plus this is giving me 90 degrees, which means that this angle here is going to be equal to 90 degrees. So in order for us to find the angle of inclination that the question is asking us for, we are going to be finding theta, which is going to be the angle that is between the two normals. So let us use dot product. Let me take 1 -2, 13 dot 0, 0, 1. It is going to be equal to modulus of 1 -2, 13, modulus of 0, 0, 1, then cosine of this angle that we are trying to find, the angle of inclination of the plane P with respect to the horizontal plane. So this is going to be equal to just 13. This is going to be square root of 174. This is going to be square root of 0 squared plus 0 squared plus 1 squared is going to be 1. Cosine theta, which means that cosine theta here is going to be equal to 13 over square root of 174. Theta is going to be equal to cosine inverse of 13 over square root of 174. And this will work out to be equal to 9.8 degrees.